You are listening to The Vocal Technologist. Spoken Tech for your ears.
Welcome along. Today we're exploring the world of really big data systems and looking at how AI is changing things in some quite surprising ways.
That's right. We're sort of pulling back the curtain on the architecture behind some massive systems you probably use every day.
And also digging into some really innovative tools and, well, concepts that are pushing the boundaries. The goal is to see what ingenious solutions people are coming up with.
And maybe uncover some unexpected challenges along the way, too. It's about how things actually get built at scale.
Okay, let's start with one that genuinely surprised me. Reddit. You think of this huge platform, over 100 million daily users, and it started with just one PostgreSQL server on a single machine.
It's wild, isn't it? An incredible journey.
How do you even start scaling something like that?
Well, it's a classic story, really. They embraced database partitioning pretty early on, splitting the data to handle all those writes.
Right, sharding.
Exactly. And for stuff like new posts, votes, comments, all that real-time action, they brought in job queues. Asynchronous processing so the user doesn't wait.
Ah, okay. So the action happens kind of behind the scenes.
And then for getting those feeds and comment threads up super fast, they layered cache servers and Cassandra.
Cassandra, the NoSQL database.
Yeah, serving up pre-calculated stuff, denormalized lists, and comment trees to make reads almost instant.
And how do they keep all those votes and comments organized across the shards?
That's where Zookeeper locks came in. Think of them as traffic controllers for the queues, sharded by subreddit. It stopped everything grinding to a halt.
Clever. So eliminating contention, that's how they get that responsive feel.
Precisely. It's that careful design that makes it work for so many users.
Okay, from one massive scaling feat to another, Atlassian. Moving 4 million Jira databases, tenant-isolated PostgreSQL databases to Amazon Aurora. That sounds monumental.
Oh, it was. And definitely not a standard cloud migration.
They had to go beyond the usual managed services, right?
Absolutely. This scale demanded custom engineering. They built their own orchestration tool.
Using
AWS step functions, feature flags for careful rollouts, and this really interesting draining process to safely move databases without disrupting users too much.
Wow. And the numbers are just staggering. You said, what, 27.4 billion files managed?
Yeah, and hitting peak migration rates of 90,000 databases a day. It's hyperscale engineering.
And the result? Better scalability, reliability.
Definitely. Big improvements in scalability, hitting that 99.99% SLA, and importantly, better cost efficiency, too. It shows sometimes you have to build bespoke for the really big problems.
Right. Okay, let's shift gears a bit. AI and data. There's this concept called the boring semantic layer. Now, why is something called boring actually pretty critical for AI?
Yeah, the name is a bit misleading, isn't it? It's actually genius in its simplicity. It's basically a lightweight way to standardize how large language models access data.
Standardize how?
By only exposing pre-validated aggregations, it drastically cuts down on SQL errors and stops the LLM from, hallucinating or making things up because it misunderstood the raw data.
So it's like giving the LLM a curated dictionary or vocabulary for the business data.
That's a great way to put it. It interacts via simple API calls list models, describe models, query models. It makes natural language access to complex data much safer and more reliable.
So the boring part is actually what makes it smart and trustworthy. I like it.
Exactly. Precision over ambiguity.
But speaking of reliability, it's not always guaranteed, even with popular open source tools. We've seen some cautionary notes about the Iceberg table format.
Yeah, this is important. Iceberg is interesting because it promised to fix vendor lock-in for data lakes.
Which sounds great on paper.
Right. But it turns out it kind of inherits some old Hadoop weaknesses, particularly around metadata management on object storage.
What kind of weaknesses?
Well, it can be slow with lots of small, frequently changing metadata files, which is common. And the guarantees around concurrency, multiple people writing at once, and atomicity, ensuring transactions complete properly, are, let's say, weaker than you might expect. Fragmentation control can also be an issue.
So the big takeaway is,
you still need a robust storage engine underneath Iceberg. Without it, teams might spend way more time fighting performance issues and managing storage space than they ever saved by avoiding lock-in.
a classic case of the devil being in the details then, even with open source.
Definitely. Architecture matters, right down to the storage layer.
What a fascinating run-through. From Reddit's humble beginnings to Atlassian's massive migration, seeing how custom solutions tackle huge scale.
And then that deceptively simple, boring semantic layer making AI more reliable.
Contrasted with the hidden complexities in something widely adopted like Iceberg. It really shows the paradox is intact.
It does. And it leaves us with a question, I think. As technology races ahead, how do we as engineers, as learners, strike that right balance?
Balance between
Between pushing for the next big innovation and ensuring the systems we build are truly robust, reliable, and importantly, efficient. Something to think about.
Spoken Tech for your ears.